All right, let's get started with lesson 4, measurements, part 1. Now we are going to use or make a lot of measurements in chemistry. And so it is important that we understand the measurement system that is used in chemistry and for this class. And so that's what this lesson is going to focus on. First of all, let's look at two types of observations that we make in the chemical laboratory. First one is qualitative or quantitative observations. These types of observations are used when we make measurements or numerical observations in the chemical laboratory. A qualitative observation are observations that are made using one or more of our five senses, which is sight, touch, smell, taste, and hear. So qualitative measurements are important using our five senses, but quantitative observations, numerical observations or measurements, are observations that we use quite readily. Now, whenever we make a measurement, we must always include three things, especially if we're doing a measurement in a chemical lab. All right. The first thing is we need to have a numerical value written down. So when you make a measurement, you write down the numerical value. We must also include the units of that numerical value. And then finally, we include the uncertainty. Now, we don't always include the uncertainty in our everyday practice of chemical problems. But whenever we do a lab, a chemical lab that requires us to make a measurement, you must record the uncertainty, which is a plus or minus value. So for instance, let's say we took a block and we determined the mass of that block. And we found out that using a instrument called a balance, that the block had a mass of 46.7 numerical units. Now the question is what is the unit that this represents, or this number represents? And according to our balance, it is in grams. So we would write the symbol gram, little g, to represent the unit. Now, the uncertainty is a plus or minus range. And we'll talk about more of what that means later on in the course of this class. But it's usually written as a plus or minus some value. So let's say it's 0.1 plus or minus. And so this would be the correct way of representing a measurement in a chemical lab. Now, if we're just doing basic problem solving, then normally we'll leave off the uncertainty and just have the numerical value and the unit. All right, so what is our measurement system that we use in science and in chemistry? Well, we use the metric system. Now, the metric system was developed in France during the late 18th century and is basically used as the system of measurement in most countries throughout the world. The United States uses the English system predominantly in our everyday world. However, when it comes to science, the metric system is used in the United States as well as the rest of the world. So what happened is that the world got together and they said, hey, we need to have a uniform system of measurement for science so that countries all over the world could communicate with each other and understand the measurement system. So the SI system was developed. And we're not going to go into all the details of the SI system, but basically the SI system which stands for International System of Units, is the system most commonly used in chemistry and throughout the world. The units for the SI system is going to be derived from the metric system. So if you understand the metric system, then you're going to understand the SI system really well, because it's very similar. Now, in the SI system, we have specific physical quantities. In other words, the measurements that we make have specific units assigned to them, and these are called the fundamental SI units. And you need to know these fundamental SI units. So for instance, if I ask you, what is the fundamental SI unit for mass, you would tell me that it is the kilogram. The abbreviation for the kilogram is kg. If I ask you, what is the fundamental SI unit for length, you would then say the meter, or abbreviation of little m. All right. The SI unit for the fundamental SI unit of time is the second. For temperature, it's going to be Kelvin. Now, this may be new to some of you because most of the time when we think of temperature, we think of either Fahrenheit or Celsius. But in the SI system, we use Kelvin. Now, that doesn't mean that we're not going to use Celsius, because we will. We'll use Celsius quite a bit. In fact, most of the measurements that you take in a chemical lab is going to be in Celsius. But then often we will convert Celsius into Kelvin to use that as our fundamental SI unit. The amount of substance is the mole, and we'll spend a lot of time on that later on in the year. Electric current is the amp, and luminous intensity is the candle. And we don't use luminous intensity much in chemistry. You will in physics, but we won't really touch on it. Really, in chemistry, the important ones are going to be these first little bit here. Mass we'll use a lot. Length we'll use to a fair amount. Time is we use a lot. Temperature we use a lot. The mole, the amount of substance, we use quite a bit. And then from time to time, we'll use the electric current. So it's important to know those ideas. All right, now here comes the big part of the metric system or the SI system that sometimes gives students trouble. And you're probably familiar with many of these prefixes that are used in the SI system or that are encountered in the metric system. And these prefixes like kilo or hecto or deca or deci or centi or milli, these are familiar words to you, and hopefully they are familiar values to you. All right? So when we hear the word kilo, it should ring or tell us something about the value of our measurement, okay, based on what we call the base unit. All right, now what we're going to do is we're going to pause for a minute and we're going to talk about the base units here. And I want you to write these down, okay? So the base units that we're going to mainly deal with for mass, for instance, is going to be the gram, okay? Now, the fundamental SI unit for mass is still the kilogram, but the base unit is going to be the gram. Length, the base unit is going to be the meter. And by the way, I'll use abbreviation gram and then a little m for meter. For time, the base unit is going to be second, which is abbreviated as a small s. And then for volume, now you'll notice that there is no fundamental SI unit for volume. Go back and look at your table there, and you'll see that there was no volume listed. Well, what does that mean? Does that mean that volume doesn't exist in the SI system? Well, no, it really does. It's just that volume, there is no fundamental SI unit for it. It has to be derived. and we'll talk about how volume is derived in our second part of lesson 4. All right. Now, for now, we're just going to say that the base unit that we're going to use is the liter, abbreviated capital L. Okay. So these are all the base units used in the SI system or the metric system. All right. Oh, and before we move on, all the base units have a value of 1. Okay. All the base units are automatically assigned a value of 1. All right. So let's go back to our prefixes now. Okay. So we have learned that the base unit right here is a value or signed a value of 1. All right. Now, kilo, what does it mean? It means it's 1,000 of our base unit. So for instance, let's say we're dealing with mass. Okay. We know that the base unit is the gram, right? Gram. Okay. So, if we have 1 kilogram, okay, 1 kilogram, that's our base unit, is the gram. Kilo, which is the prefix, means that you have 1,000 grams. All right, that's all it simply means. It just denotes that you have 1,000 of the actual base unit. So let's say we're dealing with length. All right. So length we know is the meter. So if we have 1 kilometer, all that means is that you have 1,000 meters, or 1,000 of the base unit. All right. Hopefully that makes sense to you. Okay. So here's our base unit. Let's go to like centa or centai, because you've probably dealt with centai before, okay? So let's go back to our mass again. So remember, the base unit for mass is the gram. Okay? So what if you have 1 centimeter? Okay? What does that mean? Base unit is the meter. 1 centai means you have 1/100th, that's 0.01 meters, okay? That means you have 1/100th of an actual, oh, wait a minute, we're using grams, sorry. Erase that. Should be centigrams. Probably confused. Okay. So we have 1/100th of the base unit, which is the gram. Okay. Or if we were doing with volume. All right, if we were dealing with, say, length, then it would be the base unit, again, is the meter. So if we do have a centimeter, that is going to be 1/100th of a meter. All right. A millimeter, which is, a millimeter, that's centimeter. A millimeter is 1,000th of a meter. All right. Micro is 1/1,000,000th. So a micro, which is symbol like this, micrometer. So notice I always have the base unit at the end. All right. And then the prefix comes first. All right. Because the prefix is going to tell us the value of the base unit. All right. Nano is 1/100000th, so a nanometer is 1/100000th of a meter. All right. So you need to understand the value of these prefixes. That's very important. So spend some time learning this. All right. If you have some difficulties or questions of understanding this, or difficulties with this concept, or need some clarification, then please ask for this in class, and we'll spend some more time on that, okay? So that's all I want to do with this part 1 of lesson 4 for now. So make sure you spend some time studying it and preparing for the quiz.